Good afternoon, students. This is Mr. Timulak, and this is a screencast on graphical analysis. And what I mean by that, graphical analysis is taking our data, obviously displaying it as a graph, but not only that, communicating our accuracy or our errors in our data collection, and also using this information to develop a mathematical model that relates our manipulated and our responding variables. So for this exercise, I've made a data table here, which is some generic data. The first column here is the manipulated variable, which the experimenter would change on purpose. This next column is the first trial of our responding variable. Then the second trial, then the third trial. Okay. And then finally an average of them all. Okay. Now, philosophically, there's only one true value of the responding variable. And how close we get to that true value depends on the precision and accuracy of our instruments and the precision and the accuracy of our techniques. And we're never going to get it perfect. So one of the ways we help that we try to mediate those issues is by averaging the data, okay, which we do here in our fourth column. Okay, the idea here is that we're going to be wrong about we're going to be too high in our answer just as often as we're going to be too low in our answer. And by averaging them together, hopefully we'll start to reduce our random errors and get closer to a true answer. So what that means for us is what we want to plot here over on the right is our manipulated variable on the x-axis versus the average on the y-axis. Okay, we're not interested in plotting raw data points. Now, to enter this data, I may have recorded this during my experiment in a notebook, and I just entered it manually here. You can go to Data, New Manual Column, and add as many columns as you need for your data. This last column here is not a manual column. I went to Data, and I entered a calculated column, okay, because it'll handle these calculations for us. So when I added that column, this window popped up where I named my column up here. You can also add units. This data is generic, so it doesn't have any units. Okay. And then here I made my expression. Okay, this was the first trials of data plus the second trial of data plus the third trial of data. Okay, you get those by choosing this pull-down menu here. Okay. Of course, I'm averaging, so I added those three numbers up. I put some parentheses around it because I want all of that to be my numerator. And then I divided by 3. Okay. And then I got this data. Okay. Now, also one of the things I changed here that I probably want to show you is when I first did this, it looked like this. Right? We had a lot of decimal points, but you want your precision of your data to match. Okay, these averages are not more precise than my raw data. So to get rid of those extra decimal points, I could double click on the column, open up a options window, and I dialed that back to 0. Okay, now graphing. Logger Pro actually started to try to graph for me, which was nice of it, but that's not what I wanted to have graphed. This graphed my first trial's worth of data versus the manipulated variable. What I really want is to plot the average here. Okay, so to change this to the average, you could right click on the graph itself and open up your graph options. It might open up to this tab, so choose the axis options tab. And here we can just check which data set we want or do not want to have plotted. You can actually plot more than one data set at once, but I'm going to uncheck the first trial and check the average. Okay, so there is my data, my responding variable averages versus my manipulated variable. Okay. Now, next, of course, we can come up here and go to Analyze, and we can easily hit Linear Fit, and there we have a best fit line. Okay. Now, that'll be important because this information is going to represent our mathematical model. It's going to show us the relationship between our manipulated and responding variable. But there's some error in this data. So before we want to do this, we want to kind of take a look at our error. So I'm going to click on this little box here and delete this line. It's super easy to get it back later. I want to add some error bars. So what are my error bars? Well, coming back to my data table, okay, um, my average is 19, but some of these values are above it and some are below it. So we want to illustrate that with error bars. And for this class, we can basically find the row of data that has the highest error and just report that on all of our errors. Okay, so what I'm going to do here, so I have, this is 18, that's my lowest data point here. 21 is the highest in that range, so that's a difference of 3. Here in the next row, my lowest data point is 37. The highest is 42. That's a range of 5. Moving on, we have 55 as a low in this set. 63 is a high, so that's the highest yet. There's a range of 8 between my lowest data point and my highest, and I think that's going to win it out here. Okay. So out of all this data, the largest spread in my raw data range is 8. Okay. Now remember, half of that could be above the true value and half that below it. So we're going to divide that in half and make that our plus and minus for our error bars. Okay. So to add the error bars, keep in mind we're talking about the error in the responding variable. So the vertical error bars. So I want to right click on this set of data and I'm going to go to column options, choose the average. And again, this dialog box may open to this tab. You want to choose options and come over here and click on error bar calculations. Okay. So here it's showing plus and minus 8, but I really want half that. So I could do the math in my head, make it 4, but just so you know, you can do the math right here. I'm going to type in divided by 2, which will give me an error bar that's 4 up and 4 down. Okay, so we have our error. Now we did a best fit line, but theoretically, I could have a line that goes from from this lowest data point or this lowest point in the error bar to this top one. That's still a line that's all within my error. So theoretically, the slope could be that big, or the slope could go from the top of this error bar to the bottom of the next, and that would be the minimum slope. Okay, that's still within the error, so theoretically, my slopes could be anywhere in that range. So we want to add those lines. Okay. Now to do that, we're not going to do a linear fit because that's going to make a line based on the data. We're going to do model, and that's going to make a line of our choice. Okay. Now we can also model, curves, but we want to choose. I'm going to choose the line equation here. I could input the slope and the y-intercept, but we're going to change that anyway. Okay. And there's my manual fit line. Okay. It might look like the best fit line, but it's not. Okay. Now I want to move this line around. In order to do that, I have to right click on this dialog box, go to linear fit options, and choose enable line drag. Hit OK. And now you can see there's some arrows here. I can maneuver this line around. And I'm going to drag this side to the highest point in the error bar, my first data point. And I'm going to go to the other end and drag it down so that it's touching the lowest error bar, or the lowest point in the error bar, and my last data point. Okay. So that line would represent the shallowest slope that's still within my error. Okay. Now I'm going to do that again. Actually, this can be finicky, so now that I got it where I want it, I'm going to come over here, open up the options again, and I am going to uncheck the line drag so I don't move that one around by accident, which can happen more than you think. So I'm going to go back to Analyze, Model. I'm going to add another random line. I want to enable, I'm going to right click, Linear Fit Options, enable the line drag on that one. And I'm going to drag it down to the bottom end of this error bar and the other side to the top end of the error bar in the last data point. Okay. So that represents theoretically the maximum slope that's still within my error bars. Okay. Now, this is nitpicky, but this one's not quite where I want it. It's not really on the top of that error bar, so I'm going to try to adjust that. I'm going to turn the line drag back on and see if I can't tweak it a little bit. There we go. I think that's more appropriate. I'll turn that off. So, okay. Now that's our max and minimum error bar, our slopes. And finally, I'm just going to come back, and it's just a one click. I'll put my best fit line back by hitting linear fit. Uh-oh. Well, I'm kind of glad this happened, actually. Nothing comes up because it doesn't know what data I want to draw a line for. It kind of lost track of what data it was trying to graph. So to fix that, I'm going to close that. Just right on my graph, I'm going to click and drag across all of the data points here. And as you can see over in our data column, it went and highlighted those data points, which is a good verification that it's gonna make a best fit line for the right data. And then I'll go back here and do linear fit. All right, and there's my best fit line. Okay. So there you have it. This is really what you want to click on that. This is really what you want to be communicating in your lab reports as far as a graph. Now, it's completely plausible that you don't have a linear relationship to begin with, and that's called linearizing your data. And I'm going to save dealing with that for a different screencast. But one more thing while I'm here. How do you put this into your lab report? The easiest thing is to do a little screenshot of your graph, turn it into an image, and then you can format it how you want in your word processing software. So here's the Microsoft. We're going to open the Microsoft Snippet tool, which is built into the Microsoft operating system now. I'll click New, and I'm just going to drag a box around what I want to screenshot. And there you have it. Now I can save that image and put it in my lab report. Okay. So I hope this is helpful. And let me know if there's other areas where you think a screencast will be helpful, and I will be happy to make some more. The end.